Yes, we welcome you back again. Um, it's after a while. The name behind the channel is Richard, and the channel is PSSB, Physical Sciences Silver Bullet. Today we are looking at this question. It comes from the topic photoelectric effect. Okay, let us analyze the question and we see what we can do. The question says that in the diagram below, a monochromatic light is incident on a sodium metal plate. So this is the sodium metal plate, and this is the light we are talking about. And there's something which is very important here, which you must not skip, is that the ammeter gives what? A reading. Yeah, that's the setup. So in this setup, you have to know that it is possible to make this setup and the ammeter does not give a reading. And it is also possible that you set it up and the ammeter gives a reading. So whether the ammeter gives a reading or not, what is the cause of that? So let us look at this scenario. The first question. The first question says, explain why the ammeter gives a reading. Okay. When does the ammeter gives a reading? The ammeter gives a reading under this circumstance. And under this circumstance only. What's the circumstance? The circumstance is when the energy of the incident light is greater than the work function of the metal of interest. Let me repeat. This ammeter will give a reading only if this energy which is incident, if the energy of this light which is incident on this metal is greater than the threshold energy work function of the metal. You have to know that work function is a characteristic of the metal. So we talk about work function of sodium, work function of zinc. So it is a characteristic of the metal, and it represents the energy which will be needed to make the electrons come out. So when the energy of the incident light is greater than the work function of the metal, then the ammeter will give a reading. So that's the circumstance. So that is that. So this is the only situation under which the ammeter will give a reading. When the energy of incident light is greater than the energy which is holding the electrons into the metal, and that energy is called work function. So when energy of the incident electron is greater than the work function of the metal, then the ammeter will give a reading. Now, under what circumstance will ammeter not give a reading? If the energy of the incident light is less than the work function of the metal, then the ammeter will not give a reading. Then comes another question, 1.2. It says, what is meant by monochromatic light? Okay. Now, as the word sounds, mono means one, and chromatic means color. Now, in science, what is important you have to remember is that scientifically, when you talk about a color, it means a particular wavelength, or it means a particular frequency. So then when you go back to the word, what does it mean? Monochromatic light means light of single wavelength or light of single frequency. Now we have to know that it might not be single as such, but the range is narrow. So when we talk about single, it's just a point. It's a small range which you can round up to a point. So monochromatic light is light of single wavelength or light of single frequency. In the simple language, light of one color. So that is it. So that is that. Now, when in the setup they say monochromatic, it simply means frequency is fixed unless a statement comes up and says we are changing frequency or we are changing wavelength from the set point. But when you hear the word chromatic, it means that frequency is fixed or wavelength is fixed. So let us look at this and another question which follows. Then comes another question here. The question says, compare the energy of incident light to the work function of sodium. Okay, to answer this question, what do you need to know? You need to know one important aspect from the statement. Ammeter giving a reading. The moment you see this statement that the ammeter gives a reading, it means that the energy of incident light is greater than the work function of the metal of interest. So the answer is greater. And then comes this question, 1.4. Okay, the question says the threshold frequency of sodium, we are comparing. Compare the threshold frequency of sodium to the frequency of incident light. And we are choosing from greater than, less than, equal to. To answer this question, you need to know this. You need to know that a threshold frequency is a factor of work function from this equation. And we need to know that frequency of incident light is a factor of energy of incident light. So when you look at these two equations, what do you see? You are saying that because when you look at here, Plancker's constant is the same. You understand me? So, in other words, work function represents F naught. Oh, there's something here. We need to. This is frequency of incident light. Work function represents F naught, and the incident energy of incident light represents F. And what did we say? Remember, we said that whenever you see ammeter reading, the implication is simple, that the energy of incident light is greater than the threshold frequency of the metal of interest. So what is the choice we choose here? The choice is less than. Remember the question, threshold frequency being compared to the frequency of incident light. So the answer is less than. Then comes this question. It says the brightness of monochromatic light is increased. State what happens to the kinetic energy of emitted electrons. So to answer this question, there's something you have to know. Um, um, what actually represents brightness? It is the intensity. So brightness and intensity can be used interchangeably. So what is being increased here is intensity. And then comes the question, what is the effect of intensity on kinetic energy of emitted electrons? Okay, you have to know that the intensity represents actually a number of photons striking the metal surface per unit time. And when you look at kinetic energy is an energy factor, comes from frequency or from wavelength. So in other words, the answer here is no effect. Once in photoelectric, once frequency or wavelength remains unchanged, then kinetic energy is not affected. So that's the answer. The answer is no effect. Then comes next question. It says, what is the effect on the number of electrons emitted per second from the metal surface when the brightness is increased? So remember we said increase in brightness implies increase in intensity. Now, to answer this question, you have to know actually what actually intensity is. Intensity of radiation means the number of photons striking the surface per unit time. And that one determines the number of electrons emitted from the surface per unit time. So the answer is going to be increase, because you are increasing the number of photons striking the metal surface per unit time. So you end up increasing the number of electrons emitted from the metal surface per unit time. So that's the answer, increase. Then comes question 1.53. It says you are increasing brightness or intensity of the radiation. What is the effect on the ammeter reading? To answer this question, you have to know what the ammeter reads. The ammeter reads current. And actually, to you as a scientist, what is current? Current represents the rate of flow of charge, or simply number of charge moving per unit time. So remember, what does the intensity do? Intensity has increased number of electrons emitted per unit time. And remember, electrons are the charges which are moving. So the implication is simple, that when you increase brightness or intensity, you increase number of electrons emitted from the metal surface per unit time, and that one means increase in the number of charge moving per unit time, which charge moving per unit time represents current. Thank you. So then we look at next question on the same setup. So these are the answers. And then lastly on this video comes this question. It says, state what photoelectric effect reveals about the nature of light. What does it reveal about the nature of light? Okay, to answer this question, you have to know that there are two theories in place trying to explain nature of light. One is the wave theory, which obviously you'll see somewhere. The other one is the particle theory. Some scientists believe that light exists in the form of waves, and that one can be confirmed by the behavior of light during diffraction, interference, all those properties. They reveal that light is a wave. Then the other theory says light exists in form of particles, which we call photons. And the evidence from this side is photoelectric effect. So photoelectric effect is the evidence we have that light is existing in form of particles. Those particles are what we call what? Photons. So the answer is that it reveals the particle nature of light. So that is that. So those are some of the sample questions we have taken from photoelectric effect. Remember, we don't want long videos which are so boring. So we are going to cut this video here, and on the same setup, other questions are going to come from part 2 of this question. Remember, we urge you to subscribe, and we urge you to refer this one to a friend, and also to comment and advise. Remember, the channel is Physical Sciences Silver Bullet, and the name behind the channel is Richard. Thanks for your time.